All right, so we started this new unit on solving quadratics. Remember, a quadratic is anything that has an x squared in it. So like x squared plus 2x plus 1. That's a quadratic, okay? And so far, we've gone over a couple methods already, right? We started off talking about graphing, because that was what the last unit was about. And the idea with graphing was that the solutions are where it crosses the x-axis, which was kind of nice because we already spent a ton of time graphing, so this is just one little extra step. So solutions are where it crosses x-axis. Okay, so if I just draw a little quick sketch here, so let's say that's your graph, and let's say your parabola ended up looking like this. And that means that your solutions are located here and here, right? Wherever it crosses the x-axis, that's the solutions to this quadratic, okay? And then in the last video, we went over that you can actually solve a quadratic by using roots, right? This was the idea that you get the x squared by itself, and then once you have it by itself, then you can square root both sides, okay? Which was nice in certain scenarios. However, this method, we'll put a note here, this method does not always work. Okay, it only works in certain scenarios. Okay, which is again why it's not necessarily the best. Okay, also with graphing, graphing's not going to be the best method either because it only works if it crosses at exact points on the graph, right? If it crosses between 2 and 3, for example, I don't know what that exact number is. I would have to figure that out. Okay, so the third method we're going to go into today is you can solve a quadratic by factoring it. Okay, now hopefully the word factoring rings a bell because we did spend an entire unit on factoring, right? This is the one where I talked about, I referred to these as the X method and the modified X method. Okay, now if you don't remember how to do these, I'm gonna give you a very quick recap right now. But obviously if you want more, we can do more later. Okay, so let me get this out of the way. All right, so remember X method, our equation needs to be in a certain format, right? It has to look like this: ax squared, bx, and c, okay? The way you know it's an x method is because that the a value is a 1, or there's nothing there, it's the invisible 1. So if that's the case, then x method says you draw the x, okay? The number that goes up top is the c value, and the number that goes down below is the b value. And then we're looking for two numbers, right? The two numbers that multiply to C, but at the same time, they either add or subtract to B, okay? Again, that's like a 30-second recap of what X method was. Modified X method was slightly different, right? You know it's a modified one when actually there is there's an A value that's not 1, right? So if it was like 2x squared, that would be a modified X method question. The way that works is we have to adjust a little bit. Instead of just having C up top, we actually have to multiply A times C together, and that goes up top. And then the B value still goes down below, and we're still looking for those two numbers, right? Two numbers that multiply to the top and then add or subtract to the bottom. And then once you have those two numbers, there was an extra step with modified, and that was that you have to divide by A at the end. Okay? Again, that's a quick 30-second recap of how we do modified X method. If you're still struggling with those, we'll have some more examples later on as well, okay? But once you know what those are, then we can do the zero product property, which I'll show you guys in today's example. But the key thing is that when you're solving these things, in order for us to solve it correctly, it has to be equal to 0. Okay, so I'm going to put a kind of a big little side note here. Okay, in order for us to solve, it must be equal to 0. Okay, if it's not equal to 0, we'll have to do some rearranging first. Okay. All right, so let's take this and let's apply it to a question. Let me go and scroll down a little bit. I'll leave that on the screen. Okay, so an example. Let's say the question is solve, for x. In other words, you want x equals blank, or in this case, maybe two answers, blank and blank. Okay, and then let's say our quadratic is x squared plus 3x minus 12 equals 6. Okay, well, the thing that should stand out right away is we just said it, right? It's in red above. In order for us to solve it, it has to be equal to 0, which right now it's not. It's equal to 6. So we gotta do some rearranging. So easy, quick fix. Let's take that 6 and let's subtract it back over here to the left. Okay? Again, make sure you line up numbers with numbers. That's why I put it underneath the 12. Okay? So these cancel out, leaving just 0, which is what we wanted. Okay? And over here, negative 12 minus 6, negative 18. And then the other pieces didn't change. So plus 3x and x squared. Okay, so now we have our quadratic. Now it's set equal to 0, so now we can factor it. So we look at it, we got to determine, is this an x method or a modified x method? Well, remember, the way you determine that is by looking at the a value. The a value in this question is at invisible 1. So this is just a normal x method question. So we draw the x. Remember, the c value goes up top. So negative 18 goes up top. And the b value goes down below. And we're looking for what two numbers multiply to negative 18, but at the same time add or subtract to 3. Now this is like the hardest part, right? Some people get it really fast. Some people have to think about it for a second. So if you're trying to figure out what numbers multiply to negative 18 but add to 3, sometimes it helps to make a list. So we're trying to multiply to 18. So making a list of all the ways you can multiply 18. Well, 1 times 18, 2 times 9, and 3 times 6. Okay, so those are my choices. So one of those has to work, right? Keeping in mind we do have to get to negative 18. So because we're trying to get to a negative 18, we do know that one of our numbers has to be negative and the other one has to be positive. That's the only way that you can multiply to a negative number. So if you look at all the combinations, the only combination that's like 3 numbers apart from each other would be 3 and 6. Okay, so that's going to be the combination. Now we need to be careful. Make sure you put the correct one in the correct spot. Because we want a positive 3 at the end, we should give the 6 the positive spot. And then the 3 gives the negative spot. Okay, always double check to make sure you did it correctly. Right, so negative 3 times 6, negative 18, that works. Negative 3 plus 6, positive 3, also works. So we're good. So we set up our answer, 2 sets of parentheses. It's still equal to 0, so don't forget about that. So equals 0. Our first one, x minus 3. Our second one, x plus 6. However, we're still not done, okay? We factored it, and now we can use what I said earlier, the zero product property, which says that when you have two groups being multiplied together to equal 0, what we can do is we can split this up into two questions. We can say one of them, x minus 3 equals 0, and then the other one, x plus 6 equals 0. So we split it up into two separate equations. which means we're getting two answers, which is kind of what we expected. And then these equations are super easy. Everyone should be able to solve them. It's a one-step equation. We can get rid of that -3 by adding it to the other side. So that's one answer. X equals +3. The other one, same thing, one step. It's positive already, so we're going to subtract it to the other side. So we get x is equal to -6. And there's our two answers. Okay. So just to kind of recap again, when you're trying to solve it by factoring, first decide, is it an x method or a modified x method? Okay, factor completely. And then once you have it written out like this, then you can split it up into two cases and you get your two separate answers.